America has a new spacecraft. Its name is Orion. It will take us beyond Earth orbit for the first time in a generation. It will be able to travel farther out into our solar system than we have ever gone before, allowing humankind to extend its reach to new and exciting places. Orion is not a blueprint or an idea. It is real. Across the United States, people are building, testing, and getting ready for Orion's first flight test into space. Creating a spaceship is hard work that satisfies a desire to lead, a desire to achieve, and a desire to explore. At a factory deep in southern Louisiana, workers are cutting metal, welding, and building the first Orion vehicle that will fly into space. The flight is called Exploration Flight Test 1, and it will launch an uncrewed Orion vehicle into Earth orbit. Orion has a big job. Its design allows for missions deeper into our solar system than we have ever gone before.
In NASA's history, we've designed spacecraft for sometimes very specific missions, like Mercury and Gemini. With Orion, we've designed and developed it from the beginning with exploration in mind. It can go to the moon, Mars, an asteroid, take our crews and bring them home safely. So Orion will be able to do all of those things.
As engineers prepare to test Orion in space, other tests also put the vehicle through its paces, on land, in the water, and in the air. In Colorado, engineers conduct acoustic tests, blasting Orion with a wall of sound that simulates the extreme noise and vibration experienced during a launch. More than 600 instruments test the durability of Orion's avionics, propulsion, and crew life support. Orion will land in the ocean, and at the Langley Research Center in Virginia, a 22,000-pound Orion test article undergoes a series of drop tests to certify the vehicle for water landings. The drop velocities differ from test to test, representing different landing positions and conditions Orion might face in the Pacific Ocean. Some tests even turn the vehicle upside down, deliberately. It's all a part of the test. Flying at 25,000 feet, a drop test article that mimics the Orion parachute compartment is released from a C-130 aircraft. One of many tests for the Orion parachute system, the parachutes slow the speed of the drop test article to roughly 25 feet per second as it comes to a stop on the sands of the Arizona desert. The lessons learned during Orion's parachute development are also being applied by NASA's commercial partners as they design low Earth orbit spacecraft. For safety, Orion has its own launch abort system, a 35-foot tower, which can pull the spacecraft away from danger if there are problems with the rocket it sits upon, before or during the climb to space. This test of the launch abort system, called Pad Abort 1, simulates an escape while still sitting on the launch pad. Too fast for normal cameras to observe, the test is really only visible in slow motion. Abort motors fire, applying 500,000 pounds of thrust, accelerating from 0 to 450 miles per hour in the first 2 seconds of flight. This is the kind of speed needed to escape the top of a speeding rocket. Simultaneously, another set of motors is designed to do the steering, keeping the vehicle clear of any danger and positioning the craft for a parachuted landing. Finally, the launch abort system jettisons itself, successfully completing the first flight test of this important safety feature. Engineers have gathered data from this flight and prepare for ascent abort tests, which will fire the launch abort system while on a moving rocket, a tougher and higher fidelity workout for the system. For all the important testing that takes place on Earth, the ultimate test for Orion will be in the unique environment of space.
Exploration Flight Test 1 will put critical Orion systems to the test in the real flight environments. We'll see if Orion's design performs the way we expect, and by doing that, it helps us correct any issues we find now, which will avoid costly changes to the design in the future. So it's a really smart investment to add a flight like this early in the development process.
Exploration Flight Test 1 will launch an uncrewed Orion test spacecraft on a heavy lift rocket. The launch abort system will separate from the craft. Then Orion will go for 2 orbits around the Earth. While in space, critical systems in the vehicle will be put to the test, both validating and influencing design decisions. The test continues with a high-speed re-entry, rivaling conditions a spacecraft would experience returning from the moon, and giving engineers important data about this phase of flight. Finally, the spacecraft's parachute system will be deployed for a landing in the ocean, where recovery teams will get a chance to test their techniques and equipment. For Orion, the tests will continue and the work is underway. People across the nation are pouring their skills, knowledge, and enthusiasm for exploration into the development of America's next spacecraft.
So it's an incredibly exciting time to be working on the Orion project. Of course, we're building the spacecraft that's going to take us further than we've ever gone. And the team that's working on it is extremely talented and dedicated, both from NASA and the industry team. Human exploration of space is a dream we all believe in, and we're turning our dreams into reality with the development of Orion.